Okay, well, yeah, once more, I just want to apologize on behalf of the team that this is quite, I mean, this is actually the first time. It's quite atypical that we're starting by schedule, but sometimes technology does what it does. I think we're just gonna move. So it means I'm gonna move a little bit faster in some areas, but I can assure you that if there's anything that I'm having to gloss over today, subsequent lecturers would take the time to spend some time on that and ensure that we're not missing anything at the end of the whole course. So one other thing that I just wanted to say today is that, if you're not taking anything away from this course, ensure that you at least understand inference. And here's why. A lot of the business that most of us are here for one particular purpose, because we want to observe a few cases and use the judgment we derive from those few cases to inform what judgment we would have about new cases that we deem to belong to that same class. And here's what I mean. Essentially, whether you are describing a population, or you're trying to predict, or you're even trying to figure out the relationship between some variables, what you're trying to do essentially is to say that, I have some people that I can see, or I have some cases that I can observe, but after observing these cases, just these few cases, and I use these few cases to describe a larger population. Or if I look at these cases, if I see a different case that is not included in the cases that I've seen, can what I have learned from the cases I had seen before, whether in my research or in my clinical, anywhere, can I use the impression I have formed from the cases I've seen before? Can I use it to make accurate judgments about this new case, this new patient, this new community that is coming up? That essentially is the reason why most of us are interested in scientific inference, in research. But here's the problem. And there are people who've spent a lot of time, many lifetimes, trying to figure out, are there things that we can do so that when we have a number of cases, are there procedures that we can take so that the inference we draw from those cases would be useful for us when we see another case that is not included in what we have seen so far. And those steps is what constitute the set of statistical procedures that we're trying to learn in this class, in this course. But the procedures are not enough. There's also another part to it. It's the theory, the underlying logic that we need to combine with the statistical procedures that we're carrying out for our inferences to make sense. And the study of how those procedures, what we need to do about those procedures, and what we need to do about our logic for the inferences we draw from the samples, from the cases we have observed, for it to be valid when we think about other cases that we have not observed. That is the essence of the inference, and that's what we're going to be discussing today. Okay. So essentially, I'll be talking about scientific reasoning, which is what I just described. Of course, this is not a philosophy of science class. There's a lot of debates, and I doubt that we're going to resolve any of those debates anytime soon. There's a lot of debates about how do we get to know things? How should we reason about the observations we have made in a way that it can be useful for us to make judgments about observations that we haven't made yet? But that's not the debate we're interested in now. We're just going to look at a certain way of reasoning, and I would be the first to admit that there are other ways of thinking about data, of thinking about scientific philosophy that are different from this. But we're going to be looking at what most people will call the positivist and reductionist approach, which is what I described to you earlier. Can we find a handful of cases? And from these cases, is there a way we can derive information from these cases that can tell us about other cases that we haven't seen? Then we will talk about one of the procedures that are important in being able to make valid inferences, like I described, is the way we select those cases that we're actually collecting information from. And then what we do with information that we derive from those cases, which is the domain of hypothesis testing, and the statistical, derivations that we get from that data. I will be talking about that subsequently. So for instance, in a class, let's say in this class, for instance, we have about 800 people that are signed up for this class. I might be interested in knowing whether there are more physicians in this class than non-physicians. You know, if you ask people, the easiest way to figure out, the most accurate way to figure that out is to send out a questionnaire to everybody, assuming we can get a response from all 800 people, and just ask them, are you a physician or not? But here's the problem. There are so many times when it is just so impracticable to find all 800 people, whether because some of them are just gone, are just not going to respond to surveys, or are just not going to consent to providing the data, or because it's even difficult to find some of the people in our sample to start with, or it is very costly. And that is why a lot of times what we do, sometimes we don't even need something as accurate. So for instance, I might just be interested in whether, the question I'm asking now is, are there more physicians in the class than there are non-physicians? I'm not interested in how many physicians per se. If there is a way that I can select just a subset of the class and just check within that subset whether there are more physicians or not, and the inference I draw from that will be valid for the whole class, that would be a very interesting way, because one, it would save me the time, it would save me the difficulty, it would save me so many resources. And that is why we think about samples, because a lot of times it's impracticable to think about the whole population. So I'm just going to introduce a couple of terminologies here. One, let's just think about this study that I'm talking about, where I want to figure out where there are more physicians in the class than non-physicians. The population that I'm interested in this study is actually the population of everybody who's enrolled in this class. That population is called the target population. That is the exact population that I'm interested in. I'm interested in knowing the distribution of everybody who's enrolled in this class. Now, because I can't get everybody, I'm looking for a way, I have the resources to just talk to 80 people. So I'm looking for a way to select 80 people from this 800, but still, the information from these 80 people, I want it to be useful in the sense that whatever I find from these 80 people would hold for the 800 people also. Now, these people that I'm looking at, that I'm trying to select, that is the study population. So the study population is the population that I sample.
So, from
a sample population is the population, the study population is the population that I sample for my target population, which is the population that I'm in fact interested in learning about. So, if we talk about how do I get these 80 people, it turns out that how I get these 80 people is so important, because there are several ways to find these 80 people that might give me information that would not represent what I get, what I'm interested in, which is the distribution of physicians in the 800, in the 800 size class. Say for instance, I say, okay, let's get, the thing is, let's just ask everybody who's on the call right now. Let's just find the first 80 people who answers on the call right now. One problem might be that because there's a glitch, there's a technical glitch today, most of the people who still have to go to work today might have left and not signed in on this course today. And it might be that the people who get busy on Sundays, who still have to go to work on Sundays, are actually physicians. So most of the people who are remaining on the call might end up being non-physicians. So if I just say, okay, the first 80 people here today, it might end up being that the 80 people who are left on this call here today are the non-physicians. So when I look at my distribution and I find out that, and I ask the 80 people on the call today and say, can you just tell us if you're a physician or not? We find 70 people of them telling them we're non-physicians. If I make that inference and say that, well, maybe there are about 700 non-physicians in this class, that would be an error. And why is it an error? Is it because the study population that I used does not represent, is skewed, it's different in many ways from the target population. And this is a problem that we have to contend with a lot of times when we conduct scientific research. And that is why there's a number of processes. That's why the first thing you should talk about, you should ask someone, when someone is trying to make a generalization about a larger group, is how did you select your study population? Because there are several ways in which you can select a study population that can end up giving you a study population that is not representative of the target population. Say for instance, again, so I'm just gonna move on from that exposition right now. So like I mentioned earlier, three of the biggest things that we're trying to do with statistics, three of the biggest reasons why we're here, it's either because you're interested in describing a particular population, say the population of people who are enrolled in the Stats 101 class, or the population of babies who are born in a hospital in Nairobi in January 2022, or the population of physicians who are working in Dar es Salaam in March 2022. So irrespective of what you're trying to describe, a lot of times it's not feasible for you to ask every single person in that target population. And therefore you have to select a sample and collect information from the sample and use that information to make a decision about what are the characteristics of the larger group. So sometimes what you're trying to do is to make predictions about, say, well, I can predict whether someone who's enrolled in this class would learn a lot more about statistics or not. I would say, okay, maybe we should look at some characteristics. Have they published a paper before? Have they worked in a research environment before? If we're not able to ask everybody in the group, the sample we select, we can select a sample and ask them those questions and see how well do these things predict whether people would score well on a test subsequently or not. The way we select our sample and how we process the information that we derive from these people is what is so fundamental in whether the information, the conclusions we draw from this group would actually represent what we would have drawn from the larger group. There's a caveat I want to throw in at this point though, is that when I say that when you have 80 people and you collect information from them, it can give you information about the 800 people. Well, that's true to an extent. There's an obvious advantage to that, and we've talked about that. It's feasibility and cost. It is more feasible to find 80 people. It is cheaper to find 80 people, but there's also a cost to that. There's a downside to that, which is that the information you get, even though it tells you something about 800 people, it's not exactly as accurate as what you should have gotten from the 800 people, irrespective of how you select these 80 people. If what we were interested, for instance, is knowing how many people are physicians out of the 800 people, if you select 80 people, even if you select them very well, and you find out how many are physicians amongst them, and you use that to extrapolate to the 800 people, you're very unlikely to get the actual exact number. But you will get a number that's close. Whether it's close enough, that depends on the purpose of your research, the purpose of the question you're asking. If, for instance, the reason why I'm asking is because we want to buy snacks for this class and we want to know just how many snacks should we buy exactly, maybe that would not be, maybe trying inference from 80 people would not be enough. If it's important that every single person get a snack and we don't want to buy more than the snacks we need for people. But if the question we're asking is to just know whether are there more physicians in this class, therefore, how should we do our scheduling? We might not need the exact number. We might just need to get a very rough sense. In that sense, a sample might be useful.
All right, sorry. I'd like to interrupt the class a bit. So one of the challenges that we're having is that because we're using the Zoom meeting now instead of the webinar, we inadvertently have a few people who are unable to join the class.
Oh.
So yeah, and because of the way that we had set up the classes in the past, the meetings were supposed to be closed. There was no facility to host them on YouTube. And the webinars were allowed to be hosted on YouTube, right? So now we need to like allow people to be able to follow live on YouTube. But to be able to do that, we need to sign off of this meeting and sign it back in. Okay, so I'm going to end the meeting now.
Okay.
And then, yeah, maybe we should just keep going and we'll just have people follow the recordings because, yeah.
I mean, because ending the meeting.
Right, yeah. Yeah, I'll just email people who are not able to get in and say that.
But are we having the recordings, right?
We have the recordings, yes. Okay. Yeah.
I mean, okay. It's unfortunate. I mean, but
okay, all right. So you can keep going. Yeah.
So, like I was saying, there's a cost to taking just a sample rather than having the whole population. But the advantage of following proper statistical procedures is that one, your sample is likely to represent the target population. And what do we mean by being representative? What we mean is that what you would get from this sample would be close to what you would get from the target population if you had everybody. But not just that, but also the larger your sample is, the more the size of your sample approaches the size of the population, the higher the likelihood that you would get exactly the number from the population. So let's just think about it. That might be not very intuitive, but the message I'm trying to send is that if you follow appropriate statistical principles, it is not just that we're able to estimate a figure that should approximate what we would have gotten from the whole population, but also we're able to put some bound of uncertainty around it. We're able to calculate to what extent actually, how much confidence do we actually have in the number we have derived from this sample. So for instance, say we get 80 people, we find out that from the 80 people, 50 are physicians. We do not just only know that there are 50 out of 80 physicians. We know that if we extrapolate to the whole group, meaning that we think that there are 500 people in the whole group, we know that we might be missing the number by a couple of, we might be missing the number of physicians by a couple of numbers, but we can know by how much are we actually missing this number. How confident should we be that we're actually approximating this number exactly? And how far away are we likely to be from the actual number we should have gotten from the population? And this might not sound very important right now, but trust me, there's a number of situations where the amount of confidence you can have in the number is as important as the actual number you are able to work with when you're trying to estimate or predict or describe the population. So now I'm just going to go into the actual business of sampling. So by now we understand what I basically mean by sampling. This is the process of selecting that study sample from the target population, that study population from the target population that you're interested in learning about. Now, there's so many ways in which people select these samples. One of the ways I just described to you earlier is that we could say, well, this information is very urgent, we need to find out. Why don't you just ask everybody who's on the call right now and ask them, guys, just indicate in the chat whether you're a physician or not, and let's know how many physicians we have in the class. But we know that one downside to that is that all the guys who got locked out today, right now, there are likely many more physicians among them than non-physicians. There are likely people who are taking this meeting from a call, or who are taking this meeting from the hospital, or other kind of engagements. Now, that kind of sample is called a convenient sample because it's just very convenient for me. Let me find all the people I can find right now and just tell them, guys, can you just respond? Now, let's get it very, now the other side, of convenience sampling is that we follow certain procedures that have been known to be useful in letting the study population approximate the target population. And that is what a probability-based sample is. If you have a probability-based sample, we can estimate. The estimate we get from that sample, other things being equal, does not only approximate what we would have estimated from the target population as a whole, but we can also calculate the extent of confidence that we should have in this estimate that we have. And I will be describing other ways, techniques that people use in actually obtaining a probability-based sample from a target population. So I think at this point, I'll just talk about it, right? So essentially, a probability-based sample is a sample in which we know the likelihood of selecting each person. So now in this class, we have 800 people. Rather than just doing a complex sample and saying, everybody just come up here, I can select from the 800 people in a way that I know the probability of selecting each and every one of you. I know that in this sample of 880 people that I have, what is the chance that I have set, I know the likelihood that if I select 80 people from this group, one of them would be Labaran, or one of them would be Nafisa, or one of them, I know exactly the probability that each of you in the class would get into this sample. It's because it is that probability that I would use ultimately to calculate the level of confidence that I should have had, that I should have in the estimates that I get from the sample that I eventually derive from this target population. Now, one at the core of it is what we call random selection. And a random sample is a sample in which the likelihood of each person in the target population of being in the study population is equal. Meaning that the way and manner in which I have selected my 80 people from this class, the chance that one of those 80 people could have been Adewale, or could have been Labaran, or could have been Nafisa, or could have been anybody, the chances are equal for all the 800 people that signed up for this class. Therefore, the 80 people is just a miniature of the 800 people that are in the target population. And the estimate I get from the 80 people would approximate what I get from the 800 people in the target population. And so I will talk about approaches that are useful for approaches to actually practically select a random sample from your target population. But one thing I want to tell, or I need us to understand, is that a random sample, because you see that misunderstanding in so many papers, a random sample is not a sample in which just happens randomly. No, that's not what we mean. When we talk about a random sample statistics, it's a technical term. And what it means is that you have followed certain procedures, and those procedures are ensured that the chance that everybody in your target population had equal chance of being in your study population. So because sometimes you see people who do studies and they say, well, I mean, this study, we used a random sample because we didn't do anything to select them. We just selected everybody that came around on Monday. That's not what a random sample is. That's a convenience sample. That's the exact opposite of what a random sample is as far as statistical procedures are concerned. So a random sample is not a sample where you just did nothing. It's a sample where you actually follow certain procedures to ensure that the probability of being included in the sample is equal for all the elements that are in the target population. And suffice to say that why we love random samples is because they are representative. I mean, a random sample is representative of the target population. And the bigger the random sample, the more the statistic you estimate from the random sample approximates the parameter that you're interested in the target population. So like if I use 80 people, if there were actually 576 people in the target population, in this, apart from 70 physicians among those who enrolled in this class. If I take my sample of 80 people, I might get 50 people. If I take a sample of 160 people, I might get 110 physicians from that. If I take a sample of even 320, I might get something that moves closer to the actual parameter. The larger the size, the closer the answer I get to the parameter. But not just that, I can also know how much of what are the bounds around this and how much confidence should I have that the actual parameter is actually, close to what I have estimated for my study population. So I think it's discussion time. I'm just going to hear from two people. So the task before us right now is that we're trying to select a random sample in our city, in the city where you live. So you want to select a random sample of men or a random sample amongst public health scientists in the city where you live, whether in Nairobi, whether in Dar es Salaam, whether in Lagos, whether in Harare. How would you go about that? Or whether in Monrovia. So can we have two volunteers who will tell us how you would go about, if you want to select a sample of all physicians in your city, and you want that to be a random sample. So I think Abbas is raising up his hand.
Yes, sir. Good evening, good afternoon, good morning for everybody. If I'm to select, I will look at, I live in Nigeria from Kaduna State. So I will look at the distribution of the physicians, how many are actually working in primary health centers, how many are at state level, and how many are in federal level within Kaduna State. Then based on the contribution of each, I will now ration my sample size to reflect. For example, if a teaching hospital have 100 physicians, and the other, and let's say the primary health centers have 10 or 20 physicians in the whole state, then the number of physicians that I will include in my study from primary health will be a proportion based on their contribution to the total population. The number of samples from that from teaching hospital also will be a ratio of their contribution to the final population. That's how I will go about it. Thank you.
So Abbas, that's a very interesting way to go about it. And so I think you've addressed the question of contribution very well. But what I also want you to speak to is, how do you get the people from the primary care facility that will be in your sample actually? And how do you know who to include from your teaching hospital? How do you know who exactly? Because here you need to find actual people that you would collect information from. How do you figure out who the actual people are going to be?
Okay. For me to arrive at that, like currently there is even a study I'm conducting, but it's regarding pharmacists. So like in primary health centers, they have a register of those working currently. Like while in teaching hospital, I can get it from the hospital based on speciality. So I can ration it down into specialty. Like I need a nephrologist, I need a family physician, and so on and so forth. So based on the number they contribute to the population, that's how I will still ration it down based on even in the hospital. Even in each level of the hospital or private sector.
That's cool. I'm going to take one more person, but before we go, Abbas, I want to ask you one more question. So, say now I am from, I'm the guy at Kaduna General Hospital, and now I give you the list and say, Dr. Abbas, here are all the guys here are all the physicians in my hospital with all the subspecialties and all that. But how do you select? How do you know who to pick out of those? Dr. B, can Dr. Abbas just finish responding to that question?
Okay. I can decide to do it systematically if he has the list of the physicians working in that particular hospital. If I'm looking for, let's say, 10, and there are 50 physicians in that particular hospital, I can decide to say, okay, out of every 5, I will pick 1. So that is kind of systematic, instead of me to just pick the first 10.
No random.
Hello, can I make contribution?
Can I make a contribution?
Wait, let's just finish with Abbas, and then I'm going to listen to it. We're all going to make up. It looks like it's a very interesting, it's a hot topic. There are so many people want to talk about this, and that's
Okay.
fine. Yeah, let Abbas finish. Yeah.
If I could get access to the list of physicians in each hospital, I'll follow a systematic way of sampling. But if in a process whereby, like in our setting, you hardly come across that list easily, so I will now go through and pick them at random.
Abbas, sorry to interrupt. Now we have provided you with a list in all the hospitals. That's what I'm saying. How do you move on from there?
In presence of the list, I will follow a systematic way of picking.
Describe that way to us. That's the question exactly. Describe that systematic way to us. What will you do exactly?
Okay, the systematic. If for example, General Hospital Kaduna, let's say they have 50 physicians, and out of that 50, I need possibly, let's say, 10 out of that 50. I will now follow the list. The arrangement on the list, I'll now say, okay, out of every 5, I will pick 1.
That's great.
By the time I reach 50, I would have gotten my 10 people that I'm going to.
That's great. For the benefit of time, Abbas, I'm just going to move on. Thank you for your contribution. That's very helpful.
Thank you.
Who is that?
This is Justice.
Okay, Justice, let's hear from you.
Okay, if the list has been provided for me, I
where are you speaking from to start with?
I'm speaking from Ghana.
Okay, go ahead.
Okay, I would use a different method of selecting them randomly. So once the list has been provided, I will just write their names on a sheet of paper for the list of doctors that has been provided. Then I'll place them in a bowl, then select 10 out of these 50 names that has been written on sheet of papers in the bowl randomly.
So you're going to put the 50 names in the bowl and then wrap them up and then close your eyes and pick one and then shake it up again and close your eyes and pick one again.
Yeah,
right?
Pick one till I get the 10 people, 10 physicians.
Well, that's another interesting approach. Do we have one more? So I want just one more. Okay, there are 2 more people. So I'm going to listen to Osho, Akim, and Shadrach. So let's hear very fast. What would you do with the list?
Hello, everybody. What I'm going to do with the list is that I will give the 50 people number from 1 to 50. Then if I'm going to select 10, I can say every 50 person on the list will be my participant. Thank you.
Thank you. Thank you, Akim. So Shadrach, that's the last one.
Yeah, good day. He actually said what I wanted to say. From the sample, I'll assign numbers to each of them. Then I'll pick a particular number from each of the numbers that I've assigned. Maybe 1 to 5. Then I'll partition them to 1 to 5, 1 to 5. Then I can pick the number 3 out of each of the 1 to 5 groupings. That's how I'll do it.
Shadrach, where are you talking from?
I'm speaking from Abuja.
So thank you very much. I can see more hands up, and I totally appreciate our willingness to contribute. But in the interest of time, so that we can all leave here in time, I would say that let's move on at this point. There will be opportunity to respond to other questions and polls subsequently as we move on. So we've had so many very, very interesting contributions. And at the core of it, they're all very useful contributions. But when it comes to what actually confers randomness on the sample that we're drawing, there is one particular element that's missing from each of the conversations. And I appreciate that we're very systematic, where there's a lot of system, there's a lot of order and process to what each and every one of us is trying to do. Okay, I think it's someone who says that you're going to wrap up all the names, throw in a bowl and shake together. Well, that comes close to a random process of making the actual selection ultimately. But there are so many other practical ways that now makes a random selection actually a lot easier and a lot more accurate for us in contemporary statistical practice. And we'll learn about some of them as we move on in this course. So in essence, what I'm saying is that when you have that list, after you order that list, the way you select from that list must be a way in which there is randomness in that process. It might be a roll of the dice. It might be just checking up your bowl and picking from there. It might be toss of the coin and say, for each of these 50 people, when I pick one person, I toss the coin, whether it heads or tails. If it's heads, this person is included. If it's tails, this person is not included. But the way we usually do this, these days, is to say that, okay, I now have the list from the primary health care, and I have the names of all these. So can I arrange them maybe in alphabetical or in some order? Let me assign a name, a number to each of the names. Maybe there are 50 names now. I assign 1, 2, 3, 4 to 50 to them. And then I use a computer to generate a random set of numbers to select randomly from those from the assigned numbers, from the numbers I have assigned to these names. And I'm sure when we get to our R labs or our Stata lab, well, to our Stata and R lab, sorry, to our R and SPSS labs, we would be taught how to actually generate, how to randomly select, how to use our statistical programs to randomly select a number of some numbers from a list of numbers. So the easiest way, the most practical way these days is assign numbers to them, use your computer to generate, to randomly select some numbers, the amount of numbers you need out of the number list, and then the names corresponding to those numbers you can actually include in your study. Okay, now we're going to move on. What's happening here? So now, one of the problems we would have figured out here is that it is hard. The most straightforward way to do this would have been get a list of all the public health scientists in your state or your city. And once you get a list of all of them, assign numbers to all of them. Maybe you've gotten a list of all the doctors, there are 200